Maven is kind of now, you can say, a de facto kind of tool or a particular application which is used by default for all the Java programs or Java frameworks wherever you want to use, right? So this is very popular among the Java projects, right? Now, what it is a build automation tool specifically made for Java projects, and you can manage your projects, Java projects, using the Maven tool. Okay, it helps you in building your project, in managing your dependencies, or even deploying your projects into different repositories, right? So it basically covers the complete build lifecycle of a Java project. So as I said, how software is built and its dependencies both are addressed by this particular software, which is Maven. Now Maven has got this configuration file, which is called the POM.xml. Okay, so all the configuration lies inside this file, and all the different things which you do, like building your project or defining your dependencies, what build order you want to put, directories, plugins, everything is defined inside this configuration file, single configuration file, which completely drives this Maven project. Okay, so that is called the pom.xml file. Now, there are two types of repositories in Maven, right? There is a central repository and there is a local repository. So local repository is in your local machine. Central repository is somewhere on the internet where they maintain all the different plugins and libraries which you want to download using dependencies. Okay, so it dynamically downloads all these libraries and plugins from central repository, and it stores it in your local repository, stores a copy of it in a local repository. So every time you build your project, you don't need to connect to that central repository and download it, but it will use it from the local repository. Okay, so the preference is, if it is present in local repository, it will not look out for the central repository. But if it is not present, then it will download it from the central repository. So that's the whole concept, how it manages all the dependencies and plugins. Okay, Maven is built around the central concept of build lifecycle, right? So this build lifecycle, it kind of has all the stages which is present in your project lifecycle. Okay, so there are three inbuilt build lifecycles: default, clean, and site. Okay, so the default is it handles the project deployment. The clean handles project cleaning, and then the site lifecycle, it handles the creation of project's site documentation. Okay, so these are three inbuilt life cycles. Now these life cycles has got different build stages. Okay, and these build stages are also known as build phase. Okay, so there are different build phases inside a build life cycle, and each build phase represents a stage in your project life cycle. And you can very well kind of relate it to your project lifecycle when you look at all the build phases which is present inside a lifecycle. So this default lifecycle, it contains of these all these build phases, which is validate, compile, test, package, verify, install, and then deploy. As you can see, it is going step by step, right? So in your project, first you will validate whether your project is correct or not, right? You have used everything correctly within your project. So that is the validate phase. Then you want to compile your source code. That is the compilation phase. You want to run your unit test, right? So that is the test phase. Then once everything looks fine, you want to package your compiled code, right, into a redistributable package like a jar, right? For Java, these are all the packages which you can redistribute within your team when you build your project into a particular jar. So that is the package phase. And then the verify phase, right? So that is used for running your integration tests or your automation tests, right? Then install phase, when you want to install the package into your local repository, which means it will basically store the package which you have created, the jar file, in your local repository. Okay. If you want to deploy it into a remote repository, um, then you can use the deploy phase. So it will copy the final package to a remote repository, which you can share with other projects. So similar to if you have a Nexus repository, then there you can define that Nexus repository in your Maven project, and you can use the build deploy phase so that it will deploy the package into that Nexus repository, and then anybody can go into that Nexus repository and they can access your particular project or package, right? And one other thing to note is all these build phases, right? So they are kind of related to each other. Also, when you define kind of phase which is after some phases, it will run all the previous phases as well, right? As I was saying, if you run MVN verify, right, it will run all the other phases which are ahead of this verify phase. Okay, so it will not only run the verify phase, it will do validate, compile, test, package, and then it will run the verify. So similarly, if you run the deploy phase, it will run all the phases in that life cycle. So that is how Maven works. Okay. So the next thing in Maven is something called plugins. Okay. So each build phase is also made of plugin goals, right? And a plugin goal, it represents a task which contributes to your how you build and manage a project. Okay. So there are different plugins which are available in Maven, which helps you to kind of manage and build your project. One of the popular one is Maven Surefire plugin. If you are also working on automation projects, you might be using this, right? Maven Surefire plugin. So it has got some goals, and then it can be invoked by the build lifecycle phase, which is ambient test. Okay. So by default, this plugin will run all your unit tests which you have declared inside your project. Okay. And you will think why this is how this is useful in your automation project, because we will be running integration tests in our automation project. But that is not always true. If you are working on a, say, Cucumber framework or a Cucumber project, there if you're using a JUnit with Cucumber, then JUnit are basically unit tests, right? They are considered unit test. So that time you can use the Maven Surefire plugin, and that will run your runner file, which is JUnit file, right? So it will run by default. So that's how you can use different plugins to run your unit test, integration test. You want to deploy. So there are different plugins. So you can find it in the repository, central repository. Okay. You can also define different configurations. Here you can see I can run my tests in parallel. I can increase the thread count, right? So there are other configurations also present. So inside plugins, which you can declare. By default, it will have a group ID, artifact ID, and version, right? So it will use this information to download this particular plugin from the central repository. Okay, so when you use ambient test, this plugin will be activated or it will run this plugin from your project. So that is how it is related to build phases, and plugin goals. Now, another important thing in Maven is settings.xml. Okay, so before that, so let me show you how a Maven folder looks like, or how you set up Maven in your on your machine, right? So it is pretty simple. First, you need to download the jar file. Okay. So go to this download site. Here you'll find all the different um, zip files or gun zip files, depending on what kind of system you're using. If you're using Windows, just download the zip file. If you're using Linux, Unix, then you can download the tar.cz file. Okay. So once you download this bin.zip, right, you can extract it to any local folder. I generally recommend or extract it to a folder which is in my C folder. Okay, so here if you see, I have extracted it here. And that is all you need to do. You don't need to run any particular setup or anything for Maven. You just need to extract this folder, and it will have all the different settings and things which it requires to run. The other important thing which you will require is to set the system properties. Okay. So you can go here, go to your properties, go to advanced system settings, and go to environment variables. There you will find system variables. Okay. And in path, um, go to edit. Here you should define your Maven path. Okay. Once you define the Maven path here, then it will configure it. So here, if you see, I have defined it already. You have to go till the bin directory. Okay. So once you define this environment variable, the system path for Maven, then it will be configured. And how you can verify it. So run cmd, and there just type mvn. Okay, it is trying to, okay, just type mvn version. Okay, so if you type mvn, it will try to build a project, considering that I don't have a project in this directory, so it is throwing error. But if you use mvn version, then you can see the version of your Maven which is set up on your machine. It will also show you the home directory, and Maven also requires a valid version of Java. So make sure your Java is properly configured. Otherwise, your Maven won't be configured. It runs on Java. Okay, so that's a prerequisite for Maven. So if you type Maven version and this information is not printed, then it will tell you that MVN is not a valid command type. So that means Maven is not set up on your machine. Okay, so these are the few steps which you need to do in order to set up Maven, nothing else. Okay, now the thing I wanted to discuss about is the settings.xml file. Okay, so it is contained inside this configuration folder, conf folder. You have got a settings.xml file, right? These are some of the settings which are present for your Apache Maven configuration. And very few times you need to make any changes to the settings file. But if you are working in an organization, right, sometimes you might require to uh, change the default settings of your Maven configuration. Okay, if you're working on your local, it is not required generally. But if you are working in an organization where they don't allow you to download the plugins and dependency from the central repository, but they have their own repository, then that time you need to change this settings.xml file. Okay. So the top part of it is pretty, that's the common part of it, right? So there are no changes here. It has the default XML schema, which is present in this, right? Local repository, you can change this. Currently it is cm2 underscore repo, but you can change it here as well. So it will consider that particular local repository. Now, the important part of it is mirrors, right? So there will be some default mirrors in your settings.xml also. So why do we use a mirror? Okay. So by default, it downloads all the dependencies and plugins from central repository. But as I said, in your organization, you might have your own repository. So that repository, you have to define it inside your POM.xml file, okay, which is inside your project. But if you're working with multiple repositories, okay, if it is a single repository, then it is fine. You can define it in your project. But if you're working with multiple repositories, that's when you can use mirrors. Okay, so in mirror, you can define if you want to exclude a particular repository, or if you want to use your own repository, right, from where you want to download all your dependencies or plugins. So here, if you see, I have used a Nexus repository. So it's it's not an actual Nexus repository, but I'm just showing it to you. So this is how it will look like, right? So you have to provide a ID. You have to provide a URL, right? So it will be like this: nexus/content slash groups slash then your actual repository, right? You can also provide a name tag, but it's not mandatory. Then mirror off, right? So in this mirror off, if you provide star, that means it will include everything. Okay, so it will go into this particular repository URL and it will try to find everything there. But say for example, I have declared this QA script Nexus repository in my project. Okay, and I don't want to look in that particular repository. Then I want to exclude it. So you can say comma, exclude this particular repository and look everywhere else. Okay, so it will look into this particular URL. So that is how you can segregate if you are working on multiple repositories and if you want to point your Maven to a particular repository, right? At that point of time, you can use this mirrors in your settings, which is already present, but you can change this particular settings. Okay, so if you see, this is the default mirror which is present in your settings.xml file, but you can change it as I showed you, right? So you have to define a ID mirror of, and then you need to define the URL, which is your repository URL. Okay, so this was about settings.xml. Okay, since we are talking about Maven, right? So let's also create a project. So this what I told was setting up Maven on your local, right? We haven't created a project yet. So in order to create a project, you have to have configuration in your local as well as in your IDE. Okay. So IntelliJ it by default provides you with Maven configuration. Other IDEs may require adding some additional plugins or something. Okay, so when you go to new project, you will see this integration Maven is already present. Okay, as I said, it requires a valid Java or SDK, so it is already selecting. If not, you can also download it or you can add it from your local. Okay, there is something called archetypes in Maven. Generally, we don't use while creating, but if so, archetype is kind of predefined Maven project. Okay, so these are provided by different companies. You can see Apache has got some archetypes, Atlassian has got some archetypes, right? So different companies provide these. JetBrains also had some archetypes. So these are some predefined projects which you can use. If you select this archetype, it will kind of create a structure which is specific for that particular project, right? So for say for example, Jira plugin, um, or for Cucumber also there is an archetype which is provided by Cucumber, right? Which you can use. So similarly, this is useful to reduce your some work when you are working on Maven projects. Okay, but generally, if you are trying to create your own project, you will kind of not do it. Okay, so let's create a Maven project. Now, in Maven project, there are three things, and this is common across dependencies and plugins, right? So these are group ID, artifact ID, and version. Okay. Now version, it's as the name suggests, it is the version of the software. Okay. There will be different versions which companies will be releasing as dependencies, and you need, if you want to use a specific version, you need to define it in your dependency. We'll look at that, but we can also push our own project as a dependency into the Maven central repository. There is a process, but you can still do it, right? If you have developed something which you think can be reused by different projects, you can make it and release it as a dependency or plugin into the Maven central repository. Okay, so you can release it. Now, once you release it, you will also want to release different versions of it, right? So for that purpose, this version is used. Okay. Now, artifact ID, that is similar to your project name. Okay, so whatever project name you put, that artifact ID would be auto-populated. So these two will always remain same, artifact ID and name. Yeah, and then group ID, right? So group ID is generally your company domain name. Okay, so if you are working in a company, you can use that particular company name. So say if I use com.qscript, right? So this is kind of my company domain name, com.qscript. Similarly, your company will have the company domain name. So you can use, or you can use just org.example or anything which is by default is present. So this is how it is structured. Basically, group ID, artifact ID, and version. These are the three things through which a Maven project is defined. Okay, it is also known as artifact coordinates, and that is how it basically searches in the repository, right? Using these three things. So once you define these three things, you can click on finish, and then it will automatically start building your Maven project. Okay. Uh, As you can see, a default POM.xml is provided here, and our project has got this group ID, artifact ID, and version. Okay. It is also defining our default properties. It is going to use the compiler source and target, which is the Java version 16, which is using, right? So it is defined inside this properties section. So this is the default POM.xml, which is created for you whenever you create a Maven project. Uh, Also, what it gives you is it gives you a default folder structure for managing your project. Okay, so it will create all these folder structures: source, main, Java, resources, and then source, test, Java. And you can also create a resources folder here. So this is the default structure of a Maven project: source, main, Java with resources, source, test, Java with resources. The source test Java should contain all your tests, right? or everything related to your test. And then source main Java could contain your Java code or your project code. So this is how you maintain your project inside a Maven project. Right, so this is how a Maven project looks like. And as I said, POM.xml is the main configuration file, which manages or executes your project using this configuration file. Okay. Now this configuration file can contain a lot of things. The one section is this. This is the project information, group ID, artifact ID, and version. This is the default XML schema thing, which makes it a proper XML file, right? And this is defined by Apache Maven itself, this particular section. Then there are properties which you can use for defining any particular properties. Okay. Then there could be plugins. So that's defined inside build. Okay. So this will contain your build plugins, whatever plugin you want to use. And then you can have your dependencies inside the dependencies section. Okay. So this is where you will define your dependencies. Right. There could be a lot of other things as well. Right. So I was talking about repositories. So there could be a repository section, and there are lots of other sections which are present in a pom.xml file. This is mainly used to manage and build your project. When you download this particular or install this particular project as a package into your local repository, right? So the way you define it here, it will be present inside your folder structure in the similar way. Okay, so if you go to the Maven local repository, so this is under .m2 repository, right? So you will see there are already a lot of dependencies which I have already downloaded. Right now, if you see under this com folder, I have still not installed this repository, but once I run mvn install, right? So this particular QA script which I have created, right? So it will be present inside this folder. Com after com, it will create a QA script folder. Inside that, it will have this complete package. So that is how you can navigate in your local repository. Similarly, you can navigate if you have a Nexus repository, which is a kind of external repository. Similarly, it will create this folder structure there. So that is the way it is able to find your project or it navigates through your repository, the way you define it. And that is why it is important to have a unique group ID, artifact ID, right? So if you have the same group ID, artifact ID for all the projects, you will not be able to find it. Now, the most important reason why we use Maven, you will say why we are using Maven, right? Apart from all these dependencies and all these things, why should we use it? Why can't we use it? Why we can't directly have all our dependencies in our project, right? So for that, if you don't want to use Maven, you have to add all the external libraries into your project directly. And then that is a tedious task because the versions may keep on changing. So Maven takes care of that, right? It will always point to that particular version which you are pointing here. So even if the version is changing, this project, if it is running with a particular version, it will keep on running until you don't change that version in this Maven configuration, right? And it automatically downloads and maintains everything. Once you download a particular dependency, it will automatically configure it in your libraries so you can use it inside your project, right? So all that manual task of downloading the library, adding it, configuring it into a project, all that is taken care by Maven. Okay, so that's the basic advantage of Maven, apart from all the different build phases which it takes care of for your project while you are either and it is very important or very kind of necessary when you are working on a continuous integration environment, CI/CD environment, right? If you want to integrate your project with any particular CI/CD tool like Jenkins, you need to have Maven, because that is how you can integrate it with Jenkins, where you can pass a Maven build or Maven plugin goal, right? So where it can directly call your Maven project, it will run that build phases and it will integrate it with Jenkins. So the integration becomes very simple once you use Maven if you want to integrate it with any CI/CD tool. Okay, so that's all about Maven. We'll learn more when we kind of build our Selenium project, right? We'll add some dependencies, plugins. That time we'll see how, and also how we execute our Maven project will look while building our project.